This is Module 15, Lesson 3. It's the last lesson of this module. It should be a fairly short one. There's not a whole lot to do. We're going to look at entropy. So, as you can see here, the definition of entropy is basically a measure of disorder. You also have a law of disorder, or a law of entropy, which says that basically most things in the universe are naturally inclined to go towards disorder. So it's easy to believe if you think about how much work it is to keep things organized, whether it's your room, your car, a stack of papers, or whatever. It requires a lot of work to keep things orderly, but it doesn't require a lot of work to make them become disordered. Now down here it says an increase in entropy favors spontaneous reactions. What spontaneous means is something that does not require a lot of energy to happen and will basically pretty well happen on its own. So if you have something that favors disorder or increases in entropy, then that favors it happening spontaneously. If you have something that decreases in entropy, then that favors non-spontaneous, which means you're going to have to put a lot of work into it to make it happen. So now we're going to basically practice most of this stuff because that's all there is to it, is the two words. So here's an example of states of matter as examples of entropy. If you have a solid, it's very organized. So this is very low entropy. And as you work your way towards a gas, the amount of entropy increases. So that's showing you up here too. So the entropy is more for a liquid because it's a little more disorganized. They're moving a little more freely. And then a gas is definitely high entropy. It's high disorder because they move rapidly and randomly all through the container. Now, if you could take the stopper out and remove it from the flask, what would happen is your entropy would go up even more because these can now leave the container that they're in, which means they can become even more disorganized. If you put them in a larger container, that would increase the amount of entropy as well because there's more room for them to go all over the place. Now, if you're curious about what the delta S values mean, that's just the spontaneity. So what it's basically saying, we're not going to worry about doing any numbers for this, is that it becomes more spontaneous as you go to the right and it becomes less spontaneous as you go to the left. What about reactions? We're going to do some practice with these too. If we have a reaction, we're kind of looking at two things. First of all, with this one right here, you have a solid that is breaking down and becoming a solid and a gas. So first of all, if the gas is made, we know that this has more entropy. The other thing is you have one item right here that's all lumped together as a group breaking apart into two pieces. So for two different reasons, this is increasing in entropy. One, because it's producing a gas and didn't have one before, and secondly, because it's breaking apart. Now, the synthesis reaction, it's a different one. It's not the reverse of this one, but we have two things right here becoming one. And if you looked at it, you would have two gases becoming basically another gas. So that's not necessarily going to change anything, but just the two pieces becoming one is going to make this one decreasing in entropy. Just a visual for you to think about here as far as particles go. If the particles are nice and orderly, you have high entropy, or sorry, low entropy. You have very much order, low disorder, and then higher entropy is chaos over here. All right, here's some other example problems if you were asked some of these things. So, it says choose a system with a higher entropy. You have loose stamps or stamps in an album. As you could figure, stamps in an album are highly arranged, so the loose stamps would have the higher entropy. If you have ice cubes in their tray versus in a bucket, they're nice and organized in the tray, but they're going to be dumped all over the place in the bucket, so the bucket would have the higher entropy. Okay, for these, you have water at the same temperature. They're both 100 degrees Celsius, so that can't decide it for me. If one temperature was higher, that would have higher entropy. They're both in a 10 milliliter, they're both 10 milliliters of water, so that's not going to do it for me. So this one just says water and this one says steam. So steam, we're assuming this is a liquid and that this is a gas, obviously because it's steam. Then steam would be at the higher entropy because it's in the gaseous stage. People watching the parade or the parade itself. people watching the parade are going to be sitting still, whereas the parade is going to be moving, so that would be the higher entropy. Now, what if it's more chemistry-like examples, such as these? So, and each one will just decide if it's increasing or decreasing, and then if it's favored or unfavored. This means, is it likely to be spontaneous or not? Favored means spontaneous, and unfavored is non-spontaneous. So for this one, if you have solid carbon dioxide becoming a gas, that is an increase in entropy because you have a solid becoming disorganized. And if it is becoming disorganized, then that is favored, because that's what we said earlier. Now, if you want to test your skills at the rest of these, pause the video, guess them. You can either do it one at a time or all together, and then come back and check yourself. So if we have a gas becoming a solid, that is a decrease in entropy because it's becoming more organized, which makes it unfavored. This one, we have two things becoming one, and we have a solid and a gas becoming all gas. So this one's kind of conflicting. I think you can make an argument for either one based off of what we know. From the standpoint of increasing, it's increasing because it's all becoming a gas. But it's decreasing because two things are becoming one. So this one is kind of hard to do. Sometimes you don't have enough information to decide. What about this one? Okay, I see a mixture of solids and gases again. But I have a solid and a gas becoming all solid, and I have two things becoming one. So for both reasons, entropy is decreasing, and this is going to be unfavored. For the next one, we have everything is a gas, so state of matter can't decide it for me, but I have two things becoming one. I have two particles joining together, so entropy is going down, so that is going to be unfavored. And the last one, we have two gases becoming a liquid. We looked at this one already. If we have two gases becoming a liquid and we have two things becoming one, entropy is decreasing there again, and that is also unfavored. So now it's time for you to practice some of these. If you need help, you can contact me through the messages, or you can join me during office hours.